Hello everyone. This is the second part of Macbook videos. Before starting the video, I need to have a heart-to-heart with you, which is a problem related to everyone in dr-bios.com. The technical team and all dr-bios.com staff do our best to present completely perfect, from all aspects, contents on the website, and also share our whole knowledge and experience. But sometimes some members are being unkind to us. And that causes the whole team to be disappointed. Some members purchase one account and share it with a group of people. Let me give you an example. Imagine you repair a device, and you spend so much time and energy on it, but your customer pays you 1/10 of your fee. This is definitely going to upset you. This is exactly how we feel when some members share videos or accounts. So these were the things I felt the need to talk about. Now let's get into the video. That is repairing MacBook. As I said in the previous video, without knowing the alphabet of a language, we can't read or understand the language. That's why I'll try to analyze components of circuits one by one, and then talk about their duties. For example, reference voltage generator circuit, PP bus, includes different components such as charging IC, MOSFETs, and their connections with each other. Also the communication between this circuit and other circuits. I'll analyze every small detail. But I should say that this video is for the MacBook devices with magnetic chargers. I'll talk about the MacBook devices with USB Type-C adapters later. Let me tell you the sequence of the concepts that I'm going to analyze, so you'll get to know the process. It's going to be like this. First, I'll analyze charging IC. And in the next video, I'll analyze PPBus_G3H voltage generator circuit, and SMC_reset signal controlling circuit. And in the next videos, you'll get to know more about SMC, then adapter, battery, and how these two connect and communicate with the device. And in the end, summarizing and showing their communication with each other, and sequence of generating voltages and signals, up to generating PPBus_G3H reference voltage. And in the future videos, I'll analyze different stages of devices, from S5 to S0 stages. Let's check charging IC now. The most common charging IC in MacBook devices is ISL6259, that has 29 pins, and I'll analyze each one of them. I should say that IC of this family might be used in some other devices. but the pin order might differ, or number of the pins might differ. But as I'm going to analyze the duty of each pin without considering the number of it, we can expand this tutorial to a wide range of ICs, even the ICs that are used in other brands' devices. The names of the pins might differ in those devices, which I'm not going to talk about them right now. Pin 1 in this IC is agate. That has the duty to control the first input MOSFET of adapter voltage. And the MOSFET has the duty to prevent inappropriate entrance of adapter voltage into the device, or what it's called, in-rush limiter. In other words, through this pin, the IC commands to drive, enable the first MOSFET and voltage to enter the device. And if charging IC wants to disconnect adapter voltage due to any reason, it disables this MOSFET through this pin. The next pin is DC-IN. This pin is direct input voltage of adapter for the IC itself, and it provides the voltage that's necessary for driving the IC. And if this voltage is not present on this pin, the IC doesn't work, which I'll talk more about it later. The next pin is AC-IN. This pin has the duty to detect the presence of input voltage of adapter and the value of the input voltage. I should say that you'll get to know more about how it works in the following, but I briefly tell you that by observing the specified voltage on this pin, the IC gets aware when the correct adapter gets plugged in. The next pin is VFRQ. It enables and disables fast charging process. In other words, the charging IC controls fast charging process by checking if this pin is high or low. Controls fast charging process by checking if this pin is high or low. This signal gets pulled up by PP3V42_G3H voltage, and charging IC performs fast charge process of the battery, meaning it devotes the whole power of adapter to battery. And when the device starts to turn on and receives the command to turn on, PCH causes fast charge signal to get low by sending PM_SLP_S3 signal. PCH causes fast charge signal to get low by sending PM_SLP_S3 signal and stops fast charging process. And when this pin gets low, charging IC devotes the whole power of adapter to turn on the device. I'll talk more about this process in the future videos. Next pin is ICOMP. That corrects output current generated by the IC, and it is PPBUS_G3H reference voltage. That is almost like a protection for PPBUS_G3H voltage. Next one is cell pin. That informs IC about the number of battery cells. But in this design, the number has already been specified, and by 2 resistors and voltage division, it reaches a certain range of voltage. And by 2 resistors and voltage division, it reaches a certain range of voltage. This means, when charging IC observes this pin, it determines the value of its output voltage. That is PPBUS_G3H voltage. The next pins are VCOMP and VNEG. IC uses these 2 pins to corrects the value of the generated voltage This IC uses VCOMP, VNEG, and ICOMP pins to correct the value of its output voltage and output current. The next pin is AMIN. IC uses this pin, it is output pin 2. Inform SMC how much current is being drawn from the adapter, and the SMC makes the necessary decisions. Next pins are SDA and SCL, and charging IC and SMC communicate with each other through them. In other words, these two are communication pins between SMC, charging IC, and device's battery, which communicate with each other by SMB-US protocol, which you'll get to know more in the following. Next one is VHST. This pin provides another voltage that's consumed by charging IC, and that is 3.3 volts. As you see, it's provided by PP3V42_G3H voltage in this device. As you see, it's provided by PP3V42_G3H voltage in this device. The next one is a very important pin, SMB_RST_L. It has the duty to reset the IC, which means the IC resets if this pin gets low. This signal is controlled by U5010 IC, which I'll fully explain in the next video. I should have mentioned a point in the first video, but I forgot it, and that is, in Macbook schematics, signals that end with _L are the signals that carry a message only if they get low. For example, if SMB_RST_L signal gets low, the charging IC gets reset. And if it gets high, the device works normally. So if you see a signal ends with _L on a schematic or anywhere, and if by testing the voltage, you realize the signal is low, it means that something is wrong, there is a problem somewhere. Next pin is ACOK. It's a signal that informs about the health of the input voltages. The charging IC sends to SMC, and if the necessary input voltages of the IC doesn't have the needed parameters, IC gets this signal low, the signal that was pulled up by PP3V42_G3H voltage, and informs SMC that it has not received all the necessary voltages to start working. And it is a very important pin. The next one is BMON pin. It is the pin that charging IC uses to inform SMC how much current the battery that's being charged draws from the adapter. In other words, when a battery is being charged, SMC receives this signal from charging IC and finds out how much current battery draws, or while adapter is not plugged into the device. SMC finds out the value of the current that's being drawn from battery through this signal.
Hello everyone, today I'm excited to introduce you to Finti, game-changing accounting software designed for businesses like yours. Whether you're running a repair shop, a retail store, or any service-oriented business, Finti is here to revolutionize how you manage your finances and operations. Join me as we explore the key features that make Finti the go-to solution for small to medium-sized businesses. Efficient repair shop management, Let's begin with repair shop management. Finti allows you to seamlessly handle device repairs. Imagine printing receipts with just a click or sending eco-friendly text messages to your clients automatically. No more hassle, just efficient and organized repair shop management. Invoices and financial transactions. Creating invoices and tracking financial transactions have never been easier. Whether you're issuing receipts or managing expenses, Finti simplifies the process. Plus, if your team works on commissions, Finti's got you covered. Set commission percentages effortlessly and let the software handle the calculations, providing you with detailed reports. User-friendly tutorials. Now let's talk about how to use Finti. Finti is designed with you in mind. Accessing tutorial videos is just a click away. Whenever you have a question or need guidance, simply click on the red icons within the software to watch related tutorial videos. And if you need assistance, feel free to reach out to our support team. They are ready and eager to help you whenever you need. Online accessibility and global currency support. With Finti, flexibility is key. Access your account and manage your business from anywhere, anytime using your smartphone or laptop. And guess what? Finti supports over 20 major world currencies, ensuring users from around the globe can easily navigate and utilize the platform. Don't see your currency? No problem. Our support team is here to assist you. It's customized to suit your business, whether you're in the repair industry or looking for top-notch accounting and inventory management. We can even disable features you don't need, providing a personalized experience just for you. In conclusion, Finti is not just accounting software. It's a business companion designed to simplify your operations and boost your efficiency. Join the global community benefiting from Finti's powerful features. Subscribe now, use the exclusive 50% discount coupon, and let Finti elevate your business to new heights. Thank you for watching and happy managing.
Next pin is BGATE. It has the duty to turn on and off the MOSFET that enables and disables the process of charging the battery, which I'll explain more in the following. CSON and CSOP are two pins that are connected to two sides of a resistor that's placed in battery voltage direction. And by getting sample of the voltage of two sides of the resistor, IC detects how much current is being drawn from the battery, or how much the battery draws from charging circuit. And then the charging IC and BMON pin informs this to SMC. The next pin is VDD. When IC receives its necessary voltages, it generates 5.1 volts that exits through pin 20. The voltage is provided for VDDP pin of the IC. Let's talk about VDDP now. One of the consumed voltages of IC enters the IC through this pin. One of the consumed voltages of IC enters the IC through this pin. And if this voltage gets absent, IC won't work properly. And PPBUS_G3H voltage won't be present, or the voltage will be very low. Next pin is LGATE. It's the pin that controls the low MOSFET that generates PPBUS_G3H reference voltage. Next one is PGND, and as its name represents, it's the pin that connects the IC to GND. Next pin is phase. It's a pin that gets sample of PPBUS_G3H voltage. And UGATE pin. It controls the high MOSFET that generates PPBUS_G3H reference voltage. Next pin is boot. That is connected to bootstrap capacitor. And the positive feedback voltage is connected to this pin. I should say that Mr. Nickby has fully analyzed the bootstrap in MOSFET videos.
در ویدیوی MOSFET ها کامل
You should check those videos.
در صورتی که علاقه‌مند هستن که بیشتر درباره این مسائل اطلاعات کسب کنن.
If you're interested in learning more about the concept. Next pin is SGATE.
پایه اسگیت.
It has the duty to control the second MOSFET of adapter input voltage,
MOSFET دوم ورودی ولتاژ آداپتور رو داره.
and that MOSFET prevents the reverse current from entering the adapter,
از جریان معکوس به داخل آداپتور رو داره.
which is reverse current protection.
Reverse current protection است.
I'll explain more in the following.
البته دربارش بیشتر حرف خواهیم زد.
Next ones are CSIN and CSIP.
CSIN و CSIP
These two pins connect to two sides of a resistor
یک مقاومت متصل میشن
that is placed on adapter voltage direction.
ولتاژ آداپتور قرار داره.
By getting sample of voltage difference of two sides of this resistor
دو سر این مقاومت ایجاد میشه.
and calculating the current flow intensity.
با استفاده از این دو پایه شدت جریان عبوری از این مقاومت اندازه‌گیری میشه.
Amen pin informs SMC about this value.
AMN به SMC مقدار اعلام میشه.
The last pin is
بعد و آخرین پایه هم
THRM_pad.
پد
That is bottom heatsink of IC.
سینگ کفی آیسی است.
That is connected to GND. It transfers the heat that's generated inside the IC to PCB.
ما منتقل میکنه.
So that was the pins.
این از
Now let's see how the charging IC works.
IC شارژ ما چطور کار
In other words,
یا به عبارت دیگه
how it communicates with other components.
چجوری تعامل داره.
I prepared a slideshow for this purpose,
اسلایدشوی آماده
and I'm going to analyze how charging IC works in three different situations.
در سه حالت که
When only
شارژر
charger is plugged in and the battery is disconnected from the device,
شارژر متصله و باتری به دستگاه متصل نیست.
and when only battery is connected to the device,
باتری به دستگاه متصل
and when both are
و
connected to the
حالتی که
device.
هر دو به دستگاه متصل است و مورد بررسی قرار.
But I should mention something,
این نکته رو عرض کنم
and that is
که
for when only adapter is plugged in
آداپتور متصله
and battery is disconnected, as that is not a standard form.
حالتیه که استاندارد نیست.
It can't be analyzed accurately,
دقیق آنالیز
because almost all Macbook devices work with internal batteries.
غالباً با باتری داخلی
An adapter only is not defined for them.
برای اونها اصلا کلاً تعریف نشده.
But as we repairmen usually test motherboards without batteries. That's why I'll analyze that form as well. Well, the first one that I'll analyze is adapter only, and the battery is not connected to the device in the beginning and when the adapter is enabled, which has several steps itself that I'll analyze in adapter section. As you see, the input voltage enters back side of the first MOSFET, and gate pin of this MOSFET P-channel MOSFET gets pulled up through a resistor. And causes source and drain pins of the MOSFET to be completely disconnected from each other. As I said before to those who are interested in knowing more about MOSFETs, Mr. Nickby, my dear colleague, has captured a video about them. That is the most complete video about MOSFETs. You can refer to it, the video will be linked in the article. Because if you don't know how each component works, you can't understand its function on a circuit. So let's keep going. As you see, input voltage enters a pair of diodes through another direction. As you see, input voltage enters a pair of diodes through another direction. Then it enters DCIN pin of the IC and provides the necessary voltage of IC. And through another direction, it enters a section that has two resistors. And those two resistors convert the input voltage to around 4 volts by voltage division. And those two resistors convert the input voltage to around 4 volts by voltage division. and enters ACIN pin of the IC, as I said before.
همونطور که قبلتر از کردم خدمت شما
And when IC receives the voltage,
با دریافت این
it realizes that the right, correct adapter is plugged into the device. I should say that these two resistors have another duty as well. I should say that these two resistors have another duty as well, which I'll talk about in adapter section. So adapter voltage has entered the IC,
ولتاژ آداپتور به آیسی وارد شد.
and in the next step, and after providing PP3V42_G3H voltage, an SMC_reset_L signal that will be analyzed in the next video. And as you see, these two
این دو نیز همانطور که مشاهده می‌کنید
enter these pins of the IC.
در روی آیسی متصل میشه.
SMC_reset_L enters SMB_RST_N pin of IC, and PP3V42_G3H voltage enters VHST pin. As you see, with two resistors and by voltage division,
دو مقاومت که مشخص شده
it enters cell pin of the IC.
سل آیسی میشه.
This voltage division of 3.42 volts voltage
342
is for letting the charging IC know which voltage it should generate,
میگه که وظیفه تولید چه ولتاژی رو داره.
and it specifies the final generated voltage of the IC.
آیسی ما رو مشخص.
So if any of these resistors faces problem,
هر کدوم از این مقاومت‌ها دچار مشکل شده باشه،
the output voltage PPBUS_G3H will be lower or higher than the standard,
از حد مجاز خودش
which is around 12.6 volts in this device.
12.6 ولته.
So the voltage will be lower or higher than 12.6 volts in this device. So if you repair a device that has lower or higher PPBUS_G3H voltage than standard, one of the things you should do is to check these two resistors, which you should see if the ohm is correct or not. Sometimes ohm of these resistors change due to water spillage or sulfated problems. Therefore PPBUS_G3H voltage changes as well, as each of the resistors of this device is 1 ohm.
در این دستگاه 1 کیلومتر
So the voltage that enters cell pin is
به پایه سل ما متصل
half the input voltage of first resistor,
به مقاومت اول
that is 3.42V,
342 میشه،
meaning it will be 1.71 volts,
1.72
meaning as two resistors are similar.
چون دو تا مقاومت یکی هستن.
So the voltage will be divided by 2 3.42 volts divided by 2 equals 1.71 volts,
ولتاژ 1.71
and that enters cell pin of the IC.
پایه سل آیسی ما میشه.
And in the next step, when the IC receives DCIN voltage and SMC_reset_L signal, and VHSD and cell voltages, it will generate VDD voltage, which, as I said before when I was explaining the pins, is 5.1 volts. And after passing through a resistor which is R7001,
مقاومت R7001 از همونطور که مشاهده می‌کنید
it enters VDDP pin.
VDDP ما متصل میشه.
This voltage that is generated by the IC
تولید میکنه
is consumed by the IC only.
خود IC قرار.
And when the IC receives VDDP voltage,
دریافت ولتاژ VDDP بر روی
IC disconnects ACOK signal from GND. ACOK signal that has been pulled up by PP3V42_G3H before. ACOK signal that has been pulled up by PP3V42_G3H before. And IC lets it, the signal, be high. And this signal informs SMC that, up until now, everything is okay for charging IC. So everything was through charging IC's eyes until now laughing face. Now it's SMC's turn. When SMC I/O receives data from adapter, battery and charging IC, it commands charging IC to enable input FETs. I should say that I've talked about all the data that the charging IC sends to SMC.
تا اینجا فرستاده بحث
But I
کردیم.
haven't said anything about the data that it receives from adapter and battery.
هنوز در مورد اطلاعاتی که از آداپتور و باتری گرفته چیزی
We'll
نگفتیم.
discuss about them in the future videos.
در ویدیوهای آینده به اون هم میرسیم.
In the next step,
در مرحله بعد
charging IC starts to drive input FETs of adapter. When it receives command from SMC, first, it drives the first MOSFET by getting its gate pin low. And as you see, the input voltage passes through source to drain of this first MOSFET, and it arrives at back of drain pin of the second MOSFET. And as you see, this P-channel MOSFET has aligned diode body with input voltage, and that prevents from reverse current, meaning battery voltage won't enter adapter, so that by plugging the adapter out of outlet while the jack is still plugged into the device, battery voltage won't enter the adapter. The IC that received a command from SMC on the previous step to connect voltage, it gets its SGATE pin low, and it drives this MOSFET, and voltage passes through drain pin of this MOSFET to its source pin, and after passing a resistor that you can see on this slide, it arrives at the back of high MOSFET. During the process of generating reference voltage and drawing current from PPBUS_G3H voltage, IC gets sample from two sides of this resistor and measures current that's drawn from adapter. In this moment, when SMC receives data from charging IC through AMIN pin, it monitors the process of generating reference voltage PPBUS_G3H and commands charging IC to enable and disable the process of generating reference voltage through SMB-US protocol. And the IC starts generating reference voltage using PWM technology. And during this process, it uses other supplementary technologies like Bootstrap, so that it solves problems of PWM technology. And in the end, it generates the reference voltage, that is 12.6 volts in this device, and delivers it to the consumers of this voltage. The way that the adapter is plugged out, and only the battery is connected to the device, I can say that this is when the IC is in complete relaxation laughing phase, and it doesn't do anything specific. As you see, PP3V42_G3H voltage and SMC_reset_L signal are generated in a specific process, and they enter charging IC. And at this moment, IC is waiting to hear good news from adapter. Then it realizes there is no news, so it remains in the state of waiting until adapter gets plugged in. But as PP3V42_G3H voltage has been divided, voltage division, it has entered charging IC exactly like when adapter was plugged in, which I talked about before. But as ACIN hasn't entered, the IC won't generate VDDP voltage and won't send voltage to its VDDP pin. It also won't send ACOK to SMC because it hasn't received all of its necessary voltages. And it won't disconnect the battery MOSFET that's driven as default. In the next step, SMC that has received PP3V42_G3H voltage, also SMC_reset_L signal, but as it hasn't received ACOK from charging IC, it realizes that adapter is not plugged in, and 3.42 volts that entered it is generated from battery voltage. so it starts communicating with battery by SMB-US protocol
پروتکل SMBus میکنه.
and receives all data of battery,
اطلاعات باتری رو دریافت
and it will use this data when necessary.
نیاز از این اطلاعات استفاده میکنه.
And when adapter gets plugged in,
زمانی که آداپتور متصل شد
it uses these data to charge battery with the help of charging IC.
شارژ استفاده میکنه.
Now let me talk about when the battery is connected to the device,
باتری روی دستگاه
and you plug in adapter.
آداپتور رو متصل میکنه.
Let's see what happens inside the IC.
اتفاقاتی در IC ما میفته.
As you see, the battery is healthy,
ببینید باتری ما که سالمه
and it is connected to the device,
متصله.
and PP3V42_G3H voltage is present,
G3H رو داریم
and SMC_reset_L signal is present on the IC,
که طی فرآیندی تولید شده رو روی IC داریم.
and the IC is on standby
در
mode,
حالت استندبای قرار داره.
and the reference voltage PPBUS_G3H is being provided through battery.
باتری در حال تأمینه.
Now let's imagine you plug in adapter. As you see, DCIN and ACIN voltages reach the IC,
ولتاژهای DCین و ACین
exactly like when only adapter was plugged into the device,
متصل بود
which I have explained before.
بررسی کردیم به IC ما میره.
And after that, the IC starts generating VDD voltage,
ولتاژ VDD میکنه.
and the VDDP provides the voltage for itself.
خودش رو تأمین میکنه.
When the voltage is provided,
این ولتاژ
IC sends ACOK command to SMC
رو به SMC
and informs the SMC that it received adapter voltage properly.
ولتاژ آداپتور رو به درستی دریافت کرد.
An SMC which has been informed during a different process that the correct adapter is plugged into the device.
دستگاه با خبر شده
It informs charging IC through SMB-US protocol that it's okay for adapter voltage to enter. It informs charging IC through SMB-US protocol that it's okay for adapter voltage to enter. And the charging IC drives two input primary MOSFETs one by ones, delivers adapter voltage to back of the high MOSFET. At that moment, SMC shares the data with IC.
اطلاعاتی رو که از باتری ما از طریق پروتکل SMBus دریافت کرده
The data SMC received from battery through SMB-US protocol, and it informs about the battery status, whether it needs to be charged or not. If yes, how should the battery get charged? According to these information, charging IC drives MOSFETs with PWM technology in a way that it provides the voltage needed at that moment for the battery. And after providing the voltage, by driving the controlling MOSFET of the battery, it lets battery use the provided voltage. During this process, IC gets sample of current flow intensity of two resistors. One of them is for adapter voltage and the other one is for battery voltage. Informs SMC about the status of current draw from these voltages through AMON and BMON pins, so that SMC could make proper decisions by monitoring these values. But as PWM technology has some defects as well, it uses a couple of other technologies to cover them up. As you see, one of them is bootstrap capacitor. There are videos about it on dr-bios.com, also about how PWM circuits and MOSFETs work. There are videos about it on dr-bios.com, also about how PWM circuits and MOSFETs work, which you can refer to them if you see the need. So this was how charging IC works. And you also learned about all of its pins. In the future videos, you'll see how PP3V42_G3H voltage and SMC_reset_L signal get generated. Thanks for watching, smiley face.